Hi, welcome back for part 2 of your preparation for test 18. We're going to cover weighted averages and do a quick review of substitution and elimination when you have two equations and two variables. First, I wanted to go over the weighted average question on the last test. It was really worded weirdly, and I just wanted to break that apart for you quickly. You will not have one this awkwardly worded on the test this weekend. In the Olympics, the athlete received a 75% score, and that was weighted 60%. That was weird to have a score as a percent and a weight as a percent. The second score, they give you the weight first. They say it was weighted 40% and the score was a 90%. And they want you to find the weighted average of the score. So the first event counted much more than the second event. The first event had a score of 75%. Now think about a score being percent. When you score a 75 on a test, that doesn't mean that you got 75 questions right and 25 wrong out of 100. That just means 75% of your test was done well. And so when you get a test grade, I don't tell you, hey, you made a 75%. I tell you, you made a 75. So for the scores, we're just going to keep them as a number and not a percent to help the confusion clear up. So this score of 75 weighted 60%. Now that's 60 out of 100, and you learn to write that percent as 0.60, kind of like money. The second score was 90%, and we're going to write that as 90, and that score was weighted 40%, and you learn to write that as 0.40. Now, we're going to take an average, and if the 75 score counts 0.6 times, we can multiply 0.6 times 75. That tells us how many times 75 is kind of added into the average. We could have said 75 is counted 60 times and 90 is counted 40 times, and then we would have 100 times altogether. But since we learned to convert percentages to decimals, we have 0.6 times, 0.4 times, and we have 1.0, or just 1 altogether. So we count our 75 and add that to the 90, but we multiply them times their weight. That's how many times they're counted. And then we divide it by the total number of scores counted. That would be this number 1. It's confusing. And so you would take out your handy-dandy calculator, as I am doing right here, and I would multiply 75 times 0.6 plus 90 times 0.4, and I would get 81 on the top and 1 on the bottom, which is just 81. That's the score. And up here, they report the score in units of percent. So I'm going to report my answer in units of percent. I just wanted to go over that quickly because a lot of people missed it. It was worded very weirdly. Let's go to a normal weighted question. So in this one, we have Jane's test scores. This is more like school. She made 4 test scores. She made a 70, an 80, then she made another 80, and then a 90. But those tests had different weights. The 70 score, her test that she made a 70 score, counted 1 time. So we can say times 1. The 80, the second test, counted, so here's the weight of 1. The next weight is 3, and they're in the same order. So the second test counted 3 parts, or 3 times as heavy as the first test. Kind of like in math, the second test has the information the first test has on it plus some, so it should count heavier in your average. If you do well on the second test, of course you know the first test material. So we can take the number of weights and multiply it times the score. The third test counted 5 times, and so I'm going to times 5 with that third score. And the last test counted 4 times, and I'm going to times that by 4. Now, why do I do this? If I did it the long way and I did the average, I would add the scores. 70 counts once, 80 counts 3 times, so I'd say 80 and 80 and 80. I would count it 3 times. The third score, 80, counts 5 times. 1, 2, 3, 4, 5. And you can see this takes a lot of time to write out. And then the 90 counts 4 times because that's the weight of it right here. So 1, 2, 3, 4. Now, you learned when you learned multiplication that if I have a number added 3 times, I can just say 3 times that number. And if I have a number added 4 times, I can just say, or 5 times, I can say 5 times that number. And here 90 is added 4 times, I can say 4 times that number. Now, I need to total all of this up. You can use a calculator, but you want to add all of these scores up and how many times they're included. So 70 times 1 is 70. 80 times 3 is 240. 5 times 80 is 400. And 4 times 90 is 360. And I can add these scores up. Let's see, 11, 17, 6, 10. I get 1070 as a total. Now I need to divide by how many there are. If you look up top, it's easy to see. You can count how many there are. But if I want to divide by how many there are, I can add this 1 time, 3 times, 5, and 4 all together and get 13. I have 13 weights, and so 13 is how many there are. So I'm going to look at my calculator, and I'm going to divide 1070 by 13, and that tells me that I have a new average now of 82.3. That's the weighted average of all those scores. Now we're going to run through substitution and elimination one more time. We did this in class yesterday. Substitution. Substitute means to plug it in place of another thing. So when I do substitution, I solve one equation for one letter, and then I plug or substitute for the same letter in the other equation. Okay, so we're going to begin with the easiest letter to solve for. Here we have an N of N. We treat those 2 letters like they're one letter. And of N of D with no coefficient. Those would be very easy to solve for. I could just say minus N of N minus N of N, and N of D equals 17 minus N of N. That was fast. Now everywhere in this first equation that I see n of d, I can substitute 17 minus n of n. Let's do that. All right, I'm going to rewrite that first equation down here. I have 5n of n plus 10n of d, and I'm going to put a parentheses there, equals 135. I'm going to plug in, instead of writing n of d, I'm going to write everything that n of d equals. Now I have one equation with one letter or variable, n of n. Remember, I pretend that's one letter. Now I can solve. I use all my old tricks that I learned. I see parentheses, I distribute. So I have 5n of n plus 170 minus 10n of n is 135. I can combine my n of n terms, and I can subtract 170 and get that on the other side. Remember, I'm trying to get the letter on one side and all the numbers on the other side. All of this becomes 0, and then 175 minus 170 becomes negative 35. 135 minus 170. I divide by negative 5 to get n of n by itself. And I finally find out what n of n equals. It equals 7. I found the answer to one of the variables. I still have to find out what n of d is. I can come back to the top and I can choose this first equation or this second equation or this derived equation that I concocted, and I can figure out what n of d is. This one's already telling me n of d equals 17 minus n of n. That would be the easiest one to use. I know what n of n is. So n of d is 17 minus n of n, which is 7. So n of d equals 10. That is substitution. I solve for one letter, just right here, and then I plug it into the other equation and solve. Then I can use that number to find the other variable. Let's try two equations, two variables, the same ones, but now we're going to solve by elimination. Elimination tells me I need to eliminate or kill or get rid of one of these variables. I can do that by making it have the same coefficient with an opposite sign, one negative and one positive. If I multiply this whole second equation by a number, I can change the variable coefficient. Which one do we want to eliminate? It does not matter. We can start with n of d. I'm just choosing that randomly. If I want to eliminate n of d, I need it to have the same coefficient 10, but with a negative sign. So when I multiply negative 10 times all of that, I would get negative 10 n of n, negative 10 n of d, and then negative 10 times 17. I have to multiply it times everything all over that equation. Now if I add this equation to the first equation, my n of d's go away. I eliminate my n of d's. They become 0. Negative 10 plus 5 is negative 5 n of n. And then negative 170 plus positive 135 gives me negative 35. This looks just like the one we did before. I divide by negative 5 because I want n of n by itself. And now n of n equals 7. I found one of my variables. Now I can go back and I can use any of these equations to find my other variable. This equation looks the easiest. It has the less numbers in it.